25. Here is the problem. dy dx equals cosine squared of 5x. And then it says, and y equals -2 when x equals 7. Y equals -2 when x equals 7. What is it saying? It says construct a function of the form y equals from a to x f of t dt plus c. Goodness gracious. Well, let me just get right to it. Okay, so it's got to look like y equals the integral from something to x. Put some value there. F of t. Put the function with t. So cosine squared 5t dt plus some number at the end. Okay, so this part is what we just did. That is nothing new. So how do I rig this function so that x equals 7, or that if I plug in 7 for x, I get -2 for y? Well, this is how we're going to do it. I'm going to put the 7 right here. Okay, why? Well, when x is 7, if I was to plug in 7 for x here, the integral from 7 to 7 is 0. So I'm kind of just rigging this so that at 7, this will all just go away. So if I plug in 7, they'll make this disappear, and then what's left? Just put the -2 over here. I guess I should have just written -2. Okay, but so I'm doing this when x is 7, this goes away, and y is -2. So that is my final answer. Except I should probably just have written -2 there, but oh well. Yeah. Let's try one more, number 28. Number 28, the integral from 2 to -1 of 3 to the x power dx. Okay, I need to find the antiderivative of 3 to the x power. So let me, basically, a good thing to do is just back up, just start something and see what the derivative of that would be, and then modify it. So let's say my original function might have been, well, this is a power, right? So if I had 3 to the x power, what is the derivative of that? Because I know when I have an exponent, it's just the same thing. So this is 3 to the x. If this is y prime equals 3 to the x power times what? Times the natural log of 3 times the natural log of whatever your base is. Okay. Well, so what can I do here at the start so that my derivative is just 3 to the x? Well, multiply this right here by, because you can just multiply by a constant, multiply this one by 1 over natural log 3. And that will also multiply my derivative by 1 over natural log 3. Oops, sorry. And then those will cancel out. So the derivative of this function gives me this. Okay, I just started with something and I played around with the constant until I got it to work. When we do this, let me look at the notation that we usually use here. So this is going to be 3 to the x over natural log 3. And we will use this notation a lot. Or we'll put a bracket there and put the numbers there, 2 and -1. And I know these are in the wrong order. It doesn't matter. Okay, so let's go ahead and put the -1 in first. 3 to the -1 over natural log 3 minus 3 to the second power over natural log 3. And let me see how far they simplify that. Oh, they actually made it a decimal. It's kind of odd, don't you think? Well, I don't know. I mean, I guess we have a common denominator. I could start with that. So this is 3 to the -1. That's 1/3. Oh, I don't have a common denominator. 1/3 natural log 3 minus, this is 3 to the second power. That's 9. Well, to get a common denominator, multiply both by 3. So this is 1 minus 27, or negative 26 over 3 natural log 3. That looks beautiful. So there's your answer for 28. Is it? Yes, good.